bit more of a demonstration of the GTR product here this afternoon. This is pretty much the testing of the final release. What we've added now is obviously the torque estimation and limitation control. As you can see, the monitoring items at the bottom, we've got engine torque demand, which is what the standard GTR has, and engine torque actual, which would normally be on the GTR, but we call that engine torque estimate output. Now you'll probably notice that the engine torque estimate motor is different to the engine torque estimate output, and that's down to friction changes. So when you lift off the throttle and that, to ensure that friction through the box and engine and that is actually calibrated for and actually sent out to the gearbox ECU to make sure everything is as standard as it can be. The engine torque limit, based on the torque limit required from the TCM, that actually controls the torque by a means of function, which I'll show here. So first of all, we've got the MBT torque estimate map. Okay, here you can chuck in your estimate of what the actual torque is. So that would be your actual torque. If you want to increase the clutch pressures, basically you can turn the torque up based on your given manifold pressure. So if you want to obviously clamp the clutches harder, you can do that live, and all these values are fully adjustable live. Just show you now. Normally you need to flash it, so if I change this light, you can see the engine torque estimate output changing, and as you can see it there, changing around. So that's actually live, so you can change that to see what changes you want to actually make on the gearbox. And it's also good for when you're in the launch and that. This part of the area on the launch, which will be used, say, you can manipulate that to actually find if you want the clutches to grab harder or softer or more slip. You can change the torque output of the actual torque, which will actually change all that for you. As you can see here, we've actually inputted quite a lot of torque here, mainly because we want the clutches to clamp as hard as we can, with all the extra boost in that we run off the line. Okay, you then got multipliers for TPS and air charge temperature. Obviously, with the difference in density of the air, becomes different torque. So obviously we've got a multiplier for that. Then you've got your friction torque estimate, which we've inputted there, and you've got your driver demand, which is basically your driver demand torque, which actually changes the gearbox, or tells the gearbox what the demand is from the driver. So that's based on PPS and RPM, and that then you can use that to change when the car changes gear in auto mode, etc. Because you can fool the TCM ECU to thinking that you're not demanding as much, or you're demanding more, so it changes down a gear. And again, that is all live and fully adjustable. You then got your enabled torque limitation. So when the TCM requests a torque reduction, this map here, the minimum torque multiplier by ignition retard, what that means is, based on the actual torque request to be reduced, anything that is 0.799 less than the actual torque value, it will use ignition retard. If it goes below that that multiplier, then a cut severity is applied based on what you have set in the maximum cut severity, and you can do that based on ignition or fuel. That is, it doesn't just actually cut 60% every time. It is all worked out through mathematical formulas to make the actual torque reduction to what you require. So the actual ECU will try and take out as much torque to make the engine torque motor meet what the engine torque limit is. Okay, but we've clamped it at 60% cut on ignition cut, because you really don't probably need any more torque to come out than that at full throttle. So that's obviously all there and fully adjustable. All the brake points are fully adjustable as well, so you can go in there and change your ignition retard table based on engine torque reduction. If you want to take it to low down, it's not pulling out so much time, and etc., you can do so. Okay, the bit that everyone wants to know about obviously is the launch control. In the drive-by-wire, we've now added a pedal position to throttle position target multiplier based on vehicle speed. What this is very useful to have as a kind of ramp-in effect. The one thing to remember is the last part of the actual calibration here needs to be set at 1, so that when you get over that set mile per hour, the actual drive-by-wire target system works as it would before, based on the target table here. Okay, so what you can do is you can actually change these brake points. So if you want to change it, so at the moment we've got it as a 30 mile an hour ramp in. because we're on a standard gearbox, so we want it to be looked after. If you wanted to, you could make this maximum one here, say 20 mile an hour, and then really control the ramp in on your actual table here. So as you can see, at the moment you can see it's really dumbed down. So actually, if the pedal demand was, say, if you put your foot to the ground and PPS was asking for 100% throttle, we're actually multiplying that by 0.11, so it actually gives us just above 10% throttle. Okay, so like I said, we've got a standard transmission in this car, so we've got to be careful. But if you guys have got a big, powerful transmission that's built to take anything you throw at it, then yeah, you can change this ramp in to make it come in well, as soon as you release the launch switch, which is the brake pedal. As soon as you release the brake pedal, it comes in hard as you want, and you can set that. So that's that table for you to adjust the ramp in. What you then got is the launch control. In here you can type in your base engine speed, so you can see at the moment it's at 2.5. This is basically when the brake pedal is pressed, this is the actual launch target RPM. So based on the actual drive-by-wire target that you've got at the PPS to TPS multiplier, which I was just showing you then here, that is still active during the launch down here. Okay, so at the moment the launch control would only be open 11%. So what we generally say to try and do is you need to kind of get this to be exactly as you like, the amount of throttle opening you would want with the launch control. If you want this to be, say, 100% throttle on the launch control, then you would say set this, change the brake points for this map here. So the first one is, say, 0, and the next one is then, say, 0.05. So as soon as you launch, basically, obviously the ramp in kicks in and controls the amount of torque being put down to the rear wheels. So if we go back to this and just give you a little bit of a demonstration here. So we set this back up to 0.8, and then don't want exactly full throttle, but we'll just do what we kind of talked about a second ago. We'll change the vehicle speed brake point, so this one is 0 and this one is, say, 0.4, and then interpolate that up to here, so it smooths all that out. Okay, so now allow me to have nearly full throttle. Sorry about that. Okay, so launch control. So we go into here, base engine speed, so if we say, for example, 4,000, you can then change your fuel cut severity, ignition cut severity, ignition retard. At the moment these are all fairly nice and soft, so if we go into here and actually just raise the retard values up, yeah. Again, if you really want loads of boost off the line, then ignition cut severity is the way to really go, but this is just a demonstration. So the exit vehicle speed for launch is going to be set there, and all the other parameters. Won't go over too much of that now, that's more for the tuner to be going over. So when you stamp on the brake pedal, the launch state comes to on. To show you the boost, down, and you can see there, quite easily made a bar of boost on the line. So you guys with the bigger turbos, yeah, you're seriously going to be liking this. And then adjust your ramp in map as you wish, and yeah, and go from there.